Hello everyone, this is Florence Nova Christian from K. Shroff College. In today's session, we will be seeing Newton's backward interpolation formula. We'll be having a quick glance what is the meaning of interpolation, and then we'll come back to Newton's backward interpolation formula. Interpolation is the process of finding the value of y when the value of x is given within x0 to xn value. We apply Newton's interpolation formula. There are two methods, either we can apply Newton's forward interpolation formula or backward. Newton's forward interpolation formula is applied when we are supposed to find the value of x which is closer to x0, and backward interpolation formula is applied when we are finding for the value of x which is closer to xn. For backward, we make use of backward difference table. This was your forward difference table where you had del 1, del 2 and del 3. In backward, we have backward del 2, backward del 3, yn. So we begin with the last value. If suppose in this table we are having y3, then our yn is y3. So yn plus p, del yn, p into p plus 1 upon 2 factored into del backward del 2 yn. The value of p is x minus xn upon h. H is again the difference, x1 minus x0 and so on, and the value of xn here in this table will become x3. Steps: first, construct the backward difference table, write all the values given in the table, find h and the value of p. P is x minus xn upon h. For forward, we had x minus x0 upon h. Here we have x minus xn upon h. Then write the formula for Newton's backward interpolation formula. Substitute all the values which we have in step 2, 3 and 4 and come to the answer. A student who is clear with the notation of the difference tables will be able to easily solve either the forward interpolation or the backward. Let us have a quick glance of forward and backward. You can see the difference here. P in the first, it is x minus x0, and here it is x minus xn upon h. Moving on to the problems. First problem: for the value x and f of x, this is the backward difference table which has been constructed. The question is, find f of 1.7. 1.7 is nearer to xn, that is, it is towards the last 1.7. So we apply Newton's backward difference interpolation formula. So first step, construct the backward difference table. Then our value of x will be given to us in the question, that is 1.7. We are supposed to find for 1.7. So the value of x is 1.7. xn, the last value is 2. So backward del yn will be 466. That is, from the last, take up all the values, del backward del yn, backward del 2 yn, backward del 3 yn, backward del 4 yn. Here we have up to backward del 4. So our formula also has to be up to backward del 4. H is 1. The value of p is x minus xn upon h. X is given in the question 1.7 minus xn. The last value is 2 upon h is 1, which is minus 0.3. Applying the formula of Newton's backward interpolation formula. Now we have all the values with us. Let us substitute it. After substitution, we come to the answer 301.075. The population of a town is given. Estimate the population for the year 1955. 1955 is towards the end. So we apply Newton's backward interpolation formula. First, prepare the difference table, backward difference table. Here we have x0, x1, x2, x3, x4. We have backward del 4. So our formula will go up to del 4, backward del 4. The value of x is given in the question as 1955 and x in the last value is 1961. Yn is 101. The difference you can see in the year, it is 10 years difference. So h is 10. The value of p is x minus xn upon h, which is minus 0.6. Then by applying Newton's backward difference formula, we get the value as 96.8369 approximately. Now coming to this question, x and cos x, let us see this and understand the table first. The value of x is given in degrees 0, 30, 60 and 90. Cos x is the value of y, which is a function of x. So here the function is cos x. So you are not supposed to find, we are not supposed to find any trigonometric function here, but this trigonometric function is the value of y. So y equals to f of x, and that f of x, the function is cos x. Students usually get confused here if they see any trigonometric function, logarithmic function, exponential function, but there is nothing to get confused. Whatever is the value given in the table is the value of the function of x, which is specified above. So x is already given 0. So cos 0 is a function. So cos 0 value he has written as 1. Okay, similarly cos 30, cos 60, cos 90 is 0. These are the values which is already given in the table. So the first value is x and the second is the value of y, which equals to f of x. And what is your function? Function is cos x. Okay, moving on further. The question is, given the table, find cos 80. So now here in place of cos x we are having cos 80. So our question is, find the value of y when x is 80 degrees, that is when x is 80. Now 80 is towards the ending, 60 degrees, 90 degrees, so 80 degrees is somewhere around that. So we apply Newton's backward interpolation formula. First is construction of backward difference table. Take up the values of xn is 90 and x is given as 80. The difference you can see as 30. The value of p is x minus xn upon h, that is 80 minus 90 upon 30, which is minus 0.33. Applying Newton's backward interpolation formula and then substitute the value. Be careful while you are when you are doing the simplification, when you are doing the calculations, because whenever minus value comes you have to be very careful here. And finally cos 80 value we are getting as 0.173. Now here this is another method type of problem where class interval is given. Here you can see the class interval. The class interval is given. Now class interval cannot be considered as x. A single value can be considered as x. Let us see the question first. The following table gives the information about the weight of packets and number of packets. Find the number of packets whose weight are less than 18 grams. Now the weight is given in grams. We are supposed to find the number of packets whose weight is less than 18. Less than 18. Less than means what? We are supposed to find first from the table the less than cumulative frequency. Less than cumulative frequency is less than 5. How many are there? 10. Less than 10. how many are there? 10. Now how many packets are there? 10 plus 16, which is 26. Less than 15, it will become 26 plus 7, which is 33. Then less than 20 will be 33 plus 4, which is 37, and less than 25 it is 37 plus 3, which is 40. So here we can see we are forming a less than cumulative frequency table. Now here the weight less than 5, 10, 15, 20, 25 is given, and number of packets are 10, 26, 33, 37 and 40. So this will be your values. Then again we are supposed to find for 18. 18 is towards the ending, so we apply Newton's backward interpolation formula. Your step 1, construct the difference table. Then H you can see 5, P is x minus xn upon H. X is 18 minus 25 upon 5 will give you the value of P, and substitute the values. Try this approximately. We get the answer as 36. Hope the session is clear to you. If you have any doubts, you can comment, and please subscribe for the further videos. Thank you.